Okay, we're going to go through just one question from January 2022. It's the Pearson Edexcel International A-Level in Physics. It's from paper 3, which is got this code. It's the practical skills in physics, which is done after units 1 and 2 are taught. So it's the skills and covering the core practicals, as well as the practical skills that you need to know about both for year 12 and year 13. This is the year 12 version, and we're looking at core practical 4. Core practical 4 is the use of a dual beam oscilloscope with a microphone attached to be able to work out time periods. Okay, so core practical 4 was question 5 from this paper. So question 5 from this paper had an exam question which looked like this. Okay, so I'm going to go through this because it's a core practical. Okay, so this was core practical 4. Core practicals 1, 2 and 3 come in unit 1. Core practicals 4 onwards come in unit 2. There are 8 core practicals in year 12 and 8 core practicals in year 13, and you need to be familiar with the methods that you need to be able to measure the speed of sound, for example, in this practical using a dual beam oscilloscope. Okay, so a student carried out an experiment. This is an application of the core practical. It's the same skills. To compare the speed of sound in air and the speed of sound in wood. So he's got a block of wood, he's got 2 microphones, okay? Now this is not exactly the same as the core practical, but it's using the same apparatus, so you need to be able to understand how to measure things on an oscilloscope. So this is an oscilloscope screen, it's showing you 2 peaks here and there, and we got to be able to work out something about it. So he used a long piece of wood, a hammer, and 2 microphones as shown. So obviously one microphone is closer to the hammer than the second microphone, and they got the distance between the front of the microphone and the second microphone, the front of the second microphone. The microphones were connected to a 2-beam or a dual beam oscilloscope. Now, if your school's got one, they should show you how to use it and how to measure things on it, like period and the peak value of the voltage. So basically up and down is voltage and across is time. So it's a voltage against time measurement. The student hit the wood, he said, with a metal hammer, producing a sharp sound. The sharp sound is indicated by how quickly it produces a peak and then how quickly it dies down again. So a sharp sound produces a sharp peak. Yeah, and the first one and the second one. So there will be microphone 1 and microphone 2. That travel through the air. So they're telling you that it's traveling through the air. The oscilloscope traces produced by the microphones and the time per division is given here in milliseconds, are shown. So this is what you see on the oscilloscope. Okay, so you can see that normally on an oscilloscope you will have 10 divisions, squares, so the peaks are separated by 6 complete squares, 0.6 here and 0.6 there. So total divisions between the 2 peaks is 7.2. Yeah, so if you count the total number of squares, it's 1, 2, 3, 4, 5, 6, 7, 8. So the maximum number of divisions is 8 divisions of time on the x-axis, which corresponds to 8 divisions, all set at 0.5. There, the marker is here. The arrow is pointing to 0.5 milliseconds per division. Okay, so the maximum time here would be 8 times 0.5 milliseconds. So that's be 8 times 0.5, which would be an answer of 4 total milliseconds. That's just to show you how an oscilloscope works. they haven't shown the scale for the voltage scale. Okay. The next part of the question, it says, determine the speed of sound in air. So we know the distance between the microphones in the diagram we showed you is 1.25 meters. So that would be S, yeah. And we know that it was 7.2 divisions. There's a point there, 7.2 divisions between the two peaks. And we know that the time-based setting was 0.5 milliseconds. So you have to just make sure you've measured the distance between the peaks accurately to get the first mark. They will accept 7.1, they'll accept 7.3. But if you don't do it more accurately, as accurately as either of those, you will lose that mark. Multiply by the time base to show you know how to use it. It gives you 3.6 milliseconds. Okay, or 3.6 times 10 to the minus 3 seconds, that gets you a mark. Once you know that the distance is 1.25 meters, and you know the time from the oscilloscope, you can work out that the speed of sound is the distance, 1.25 divided by the time taken, gives you an answer of 347 meters per second. So the first thing they want you to know from Core Practical 4 is how to use the time-based settings to measure time or period on an oscilloscope. Okay, so although we didn't actually have the full equipment in the school where I'm currently working, we were able to show them with a signal generator how you can measure the period of any frequency that you've put into the oscilloscope. Okay, so the next part of the question. Part 2. The student then attached the microphones to the piece of wood. Doesn't say how, and doesn't matter how. So now you just got to realize the first bit was for the speed of sound in air. And now we're going to look at the what happens when the microphones are attached to a piece of wood. So they detected the sound passing along the wood. Well, the distance between the microphones stays as 1.25 meters. The student adjusted the dial on the oscilloscope. Remember before it was on 0.5 milliseconds. He's adjusted to 20 microseconds per division to display the traces from the microphones. So if we just have a look at the time base on here, so he's changed it from 0.5 to the microseconds setting, and I often get year 12 students asking me if they have to remember what micro and milli and all the prefixes means. Yes, you do need to know all the common prefixes. So he's put it on a much smaller scale so it can measure a faster sound, because obviously sound travels faster in dense mediums. Okay, so in wood it will travel much faster than it does in air. Just going to move the paper up. So the teacher commented that this was not the correct setting. Yeah. Now we've got to justify whether the teacher is right or not. Justify the teacher's comment. Okay, these are often kind of questions you get in the practical skills experiment. So it's not so much on theory, but it's on the skills that you need to develop as a scientist. The piece of wood is made of oak. Not really relevant, but that's what it's telling us. The speed of sound in oak should be approximately 4,000 meters per second. So if the time base is on 20 microseconds, now remember how I showed you, if you know that there are 8 divisions on the screen, you can work out the total time that you can measure between the two peaks would be, if the first peak was here and the second peak was there, it would be not 8 times 0.5 milliseconds, but 8 times 20 microseconds. So if you multiply 8 by 20 microseconds, that will give you a total time that's available, yeah, be 160 microseconds would be able to be measured across the screen. So if the two peaks would fit on that 160 microseconds, then it would be possible. So you might now get a hint as to why the teacher had made that comment. So the maximum time across the screen would be 160 microseconds. You get 1 mark for working that out. So that's a maximum time difference you can measure. And since we know that S equals ut, or t is S over u. Remember that S hasn't changed. S is still, the microphones are still placed 1.25 meters apart. And this time the speed of sound is what we're going to use, but this is the speed of sound in oak, which is given as 4,000 meters per second. So if you want to work out the time between the peaks, it would be the two microphones, it would have to travel 1.25 meters further, and since it's traveling at 4,000 meters per second, it would take 3.1 times 10 to the minus 4 seconds to reach the second microphone. Well, we're on the microsecond scale, so 3.1 times 10 to the minus 4 microseconds is 310 microseconds. Well, that's more than the total time that could fit on the 8 divisions that the oscilloscope has on the x-axis. So therefore you would say the time delay, the time display, so time on the display available is maximum 160 microseconds, is too short to show both peaks, which would be 310 microseconds apart. So it's better to use the next setting up, which would be 50 microseconds. So if you used 50 microseconds, so you move it to this one, then 8 times 50 microseconds would give you 400 microseconds range in time, and 400 microseconds would allow you to measure the time between the two peaks. So this is a very good question to help you see how they use the core practicals and ask you questions which are applications of what you've learned in the lab. They will not be always exactly what method you use to do your experiment. The question then goes on. So this is an 11-mark question. The Unit 3 exam is worth 50 marks in total. So this is the last question in the paper, question 5. So you often 4 or 5 questions are given. Okay, so part B, the student tried the same experiment using a rubber hammer rather than the original one, which was a metal hammer. Rubber hammer compressed as it hit the wood. So if it compressed, it would be in contact with the wood for longer. This, you know that from your understanding of materials in Unit 1. Making a sound that lasted for a longer time. So if it lasted for a longer time, the peak would be less sharp than the ones that we saw in part A of this question. Explain the effect that using the rubber hammer had on the accuracy of the time determined. Well, the peaks would be wider, yes, or less sharp, you could say. So it would be more difficult to judge the position of the peaks as precisely. So time reading would be less accurate. So that's how I would get the 2 marks, by explaining the difficulty of using a less sharp sound. Okay? So again, it's a practical skills experiment. They then give you part C. The student was given the following equation, which is the speed of the, in oak, V, is equal to E, where E is the Young's modulus, which you've met in Unit 1 for oak. And they're giving you value with an uncertainty of the value. So it looks like it's a question on comparing uncertainties. The following equation and data to find a value for the speed of sound. So you know that, you know this, and they're giving you the density of the oak as 650 kilograms per meter cubed. Remember, the density of water is 1,000 kilograms per meter cubed. And this had an uncertainty of 3%. So they want you to compare the uncertainty given here with the 3% uncertainty that they know the density of oak for. So both of them are under the square root sign. So they are asking you, can you assess which of these values, they mean the Young's modulus or the density, was the more significant source of the uncertainty in the value of speed? So what happens when you want to combine uncertainties is the percentage uncertainty of V will be equal to the percentage uncertainty of each term that you combine it. each term in the equation on the right hand side. Okay, so all you have to do is to work out, since they're both under the square root sign, this is how you would normally work it out, but you don't need to know it in detail any more than that for this question. But if one was a power, like e squared, and one wasn't a power, you'd have to work out the percentage uncertainty differently. But because they're both square rooted, the percentage they bring is basically all you need to compare. Now, if you work out the percentage uncertainty of Young's modulus, which is 0.5 out of 11.2, you basically say it's 0.5 divided by 11.2 multiplied by 100 to get this percentage. And it's approximately 4.5%. So you then say, since 4.5% or 4.46% is greater than 3%, the Young's modulus value is the more significant source of uncertainty in the velocity equation. So they both contribute a percentage uncertainty to the final answer. And this is a simple treatment of uncertainties, but you do need to look at more questions to be able to see the scope of the uncertainty questions that they give you. So I thought it would be quite useful in looking at, rather than a theory paper, for those of you studying Unit 2 right now, how they could give you a question on the core practicals. They can also give you questions on core practicals, and I'll do one for core practical 5, and they can give you questions either in the theory paper or in the practical paper. So I will go through core practical 5 with you in another video, which has actually been already prepared, but it hasn't been uploaded yet. It will be uploaded by Friday. Okay, so in about 4 or 5 days time. So look out for that. So if you've found this video useful, make sure you like the video, share it with your friends who are doing the same exams as you. And if you want to know exactly when the next video will be ready, just make sure you subscribe and hit the bell notifications, so then you will be notified. Okay, well, thank you very much for paying attention in this video, and I'll hopefully see you in future videos. Thank you very much. Bye for now.